Hello, can you hear me? Good morning, can you hear me? Okay. Good morning, everyone. Good morning. Okay, so we will do some problems based on the things that we studied last time, right? If you remember dimensional analysis and if you have gone through the video, so dimensional analysis has three uses. We have studied three uses for them. One is to convert from one system of units to convert from one system of units to another, right? This is the first use. Second use is to check correctness, of a physical relation, right? If there is a formula, we can use this dimension analysis to check whether the formula is correct or wrong. And number 3 is to derive a physical relation, right? So these things we have studied last time. Let's do some problems based on them. Okay, so first question is let me just erase this. So first one is convert in using dimensional analysis. So we'll use the dimensional analysis to convert from one system of units to another. So you can see here the units given is kilometer per hour. We have to convert it to meter per second. Now from the unit itself you can make out what this is. This is what your speed, right? This number must be speed. How did I know? From the units, meter per second, kilometer per hour, it's speed, right? So first we have to know the dimensions of speed. Now formula for speed, what is the formula for speed? It is distance divided by time, right? This is the formula for speed. Distance is a length, so its dimension will be L. Time dimension is T, right? So together combining we can write L T minus 1. Okay, so this is the dimension of speed. So we will use this to convert from kilometer per hour, kmph, kilometer, p stands for per, so it's like kilometer per hour. Okay, so I can write like this also, or I can write ph also, per hour is the same thing. Okay, to meter per second we will convert. So how to do? So given units, let us see what are given units. Given units, so we don't know what system of units is this, that's why I have written given units. So S, let us call this S for speed. How much is the value given to us? 18 by 5, right? 18 by 5. Next, so what is the, so L and T, right? Now what is the smallest value of L in this unit? It is 1 kilometer. 1 kilometer, L is length, right? So according to the units given to us, they are using kilometer, so 1 kilometer will be the smallest. Next, T, right? Look at the, I'm following this. Okay, so L and T, I need L and T, so that's why I'm writing L and T. I don't need mass, so that's why we don't write M and all, right? So T1. Now look here, hour, right? So it's 1 hour. Now I need to convert to meter per second, so it's SI unit, so SI units, right? Let us call that S dash. Okay, the one that we will find out now, let us call it S dash. We don't know, so let me write question mark for that. So L2, what is the smallest unit of length? Meter, right? Look at the units, 1 meter. T2 is 1 second. Okay, so, I hope it's clear so far. If you have any doubt anywhere, just write in the comment box. Okay, so let's see how do we do it. So since they are the same thing, so we can write S L1 T1 minus 1 must be equal to S dash L2 T2 minus 1, right. Okay, so they are the same thing, even though we are converting from one system of units to another, they are the same thing, right. So now let us put the values. Okay, so we want to find S dash, so let me do this. S dash will be equal to S L1 T1 minus 1. Now this part will come down, right. So because I am trying to find the value of S dash, so I am taking this to the left side, right. This is what we will get. Next line will be S, I can group the L together and T together, so L1 by L2, and another term will be T1 by T2, but there is a power for both of them and common power is minus 1. Okay, I hope it's clear so far. S, now value of S from here if you see is 18 by 5, so 18 by 5. L1, what is L1? 1 kilometer. What is L2? 1 meter, right. In the same way, what is T1? 1 hour. What is T2? 1 second, minus 1. Okay, so 18 by 5. Now I need to convert to the same units, right. This is kilometer, this is meter, so I have to convert it to meter. I have to convert this to meter. So I hope you know this. 1 kilometer is 1000 meter, right. So divided by 1 meter. In the same way, since we are converting to seconds, so this hour also we have to write in seconds. So I hope you know this. 1 hour consists of 60 minutes and each minute consists of 60 seconds. So total seconds will in 1 hour will be 3600 seconds. Okay, so that's what I'll write here, 3600 seconds divided by 1 second to the power minus 1. I hope it's clear so far. Now 18 by 5, I'll write like that itself. Now I can cancel the meter here. What will be left? 1000. Now here it's also I can cancel these. So what will I get? I will get 3600 to the power minus 1, right. 18 by 5 into 1000. What is the meaning of to the power minus 1? So anything to the power minus 1 means the reciprocal, right. A to the power minus 1 means 1 by A. A to the power minus 2 means 1 by A square, right. I hope you know this. So it will be 1 by 3600. So let me cancel these out. So 18 times 2 is 36. So 2 will cancel with this 10, 5 will be left, 5 will cancel with 5, the answer is 1, right. So S dash is equal to 1, or therefore 18 kilometer, 18 by 5 kilometer per hour is equal to 1 meter per second. Okay, is it clear, yes or no? If it's not clear, just tell me. And this is an example, so let me write in a box. Okay, this is an example. Yes, if it's not clear, please tell. Okay, so next one, what is the next question? 5 by 18 meter per second into kilometer per hour. So the reverse of this. Okay, we are supposed to do the reverse of this. So I don't want to try this, it's the same thing, right. What will happen here? Your S will be if 5 by 18, L1 will be 1 meter, T1 will be 1 second, and you have to convert to this units, right. So S dash you have to find in this case. L2 will be 1 kilometer, T2 will be 1 hour. Okay, so it's the reverse of this, understand, nothing different, is the reverse. I think you can do this. Can you do that? Will you be able to do question number 2? Yes or no? So I'll go to the third one. What is question number 3? 13.6 grams per centimeter cube into kg per meter cube, right? So you have to convert 13.6 gram per centimeter cube to kg per meter cube. Okay, so if you look at the unit, this is the unit of density, right? Density is the unit, from the unit itself I can find out that it is density. Density is mass by volume. Okay, mass divided by volume is called density. Okay, so from this I can find out the dimension of density. But even if you don't know the formula, suppose I did not know that this is density, still you can find out. How will you find out? See, so look here, gram per centimeter cube is given to us, right? Gram is the unit of what? Mass. So this, instead of gram you can write mass here, right? And centimeter cube, centimeter per centimeter cube, that means divided by okay, okay, let me do this. So this means gram divided by centimeter cube, right? Now gram is the unit of mass, so this will be capital M. Centimeter is the unit of length, so this will be L. But how many are there? 3. So cube. So if I combine these two, I will get mass. This is the dimension of the thing that we are trying to convert. Okay, whatever this is, I have told you density, but suppose you did not know, then this is the dimension of that thing that you are supposed to convert. Okay, we need to know this. Okay, so dimension of given values. What are dimension? Dimension is M L minus 3. Okay, so what do we do first? So we don't know what this is. I will not call it D, so I'll call it something else. Let us call it P. Okay, so what is given? 13.6 given units. Okay, this is CGS unit, if you can see, so I'll just write CGS unit. So CGS unit are given to us, so CGS unit, so P is that value. G, now so look at the dimensions M and L, we need M and L. So M1, what is the smallest value? 1 gram, right? And L1, what is the smallest value? 1 centimeter. Okay, we need to convert it to SI unit. If you can see, this is SI unit. SI unit, let us call it P dash, the value that we want to find out, so we don't know, so question mark. M2, what is the smallest value here? Kg, so 1 kg. L2, smallest value is 1 meter. Okay, I hope you are understanding so far. So now, as I said, they will be equal even though we are converting to different units. So I can write M1 L1 minus 3 will be equal to P dash M2 L2 minus 3, right? So I need to find P dash, so this will become, I am taking this to the left, but I can write this way also, P M1 L1 minus 3 divided by M2 L2 minus 3. To write separately, P M1 by M2, there is no power, so we will not write. L1 by L2 to the power minus 3, common power, right. Now I will put the values. How much is P? P is 13.6, right. M1 is 1 gram, M2 is 1 kg, right. L1 is 1 centimeter, L2 is 1 meter. Again, what do we do here? We convert it to the same units, right. We convert it to the same units. We can convert this gram to kg, or we can convert kg to gram, right. The easier way will be to convert kg to gram. Okay, if I convert gram to kg, I will get 0 point something, so which will make us make it difficult to cancel and all. So let me convert kg to gram. So 1 kg is 1000 gram. I hope you know this, 1000 gram, right. Okay, minus 3 is missing here. Okay, so 1 centimeter here. Again, we have to convert this to centimeter. I am converting it to centimeter because it is easier to cancel, right. So minus 3. So 13.6 gram cancels out. So into 1 by 1000. Again here centimeter cancels out. I will get 1 by 100. So you see 100 is left here. What is, how do you write 100 in terms of power? 10 square, right. 10 square is 100. So instead of 100 I am writing 10 square, and minus 3 is there, right. Okay, so this will become 13.6. What is the meaning of 1000? 1000 means 10 to the power 3. Now look here, what will this give me? 10 square and minus 3. This will become 10 to the power minus 6. I hope you understand this, right. If I have 1 by 2 whole thing cube, what is the meaning of this? This will become 1 by 2 to the power 3, right. In the same way, suppose this is minus here, then this will become minus. Understand? I am not doing anything on top because 1, right. So no matter what is the power, it will always be 1. So that is why I did not write any power on top, because it is 1. Understand? So now 13.6 into, now if I want to bring this all the powers of 10 to the numerator, that means above, right. So this is plus, right, plus 3, 10 to the power plus 3. So if it comes up, it will become minus. So 10 to the power minus 3. Now look here, this one 10 to the power minus 6. So if it comes up, the sign will change and it will become plus 6, right. So answer will be 13.6. Now look here, same base, right. These have the same base. I hope you know this. A to the power m into a to the power n is equal to what? A to the power, you add the powers, right. In the same way, a to the power m divided by a to the power n will be m minus n. Okay, so I hope you know this. So here, since same base, so minus 3 plus 6. So answer will be 13.6 into 10 to the power 3. Okay, so this is your answer. That means 13.6 gram per centimeter cube will be 10 to the power 3. What units? Kg per meter cube. Is it clear? Yes or no? Is it clear? Anyone any doubts? Okay, so before I move on, I just wanted to say that when I ask you to give your roll number, you should give only during that time. Okay, I give you 1 minute to tell your roll number, you should give only during that time. If you give me later, I will not accept, no matter what is your reason. You say you don't have network or anything, I will not accept. Okay, when I tell you give your roll number under this minute, then you have to give me during that time, otherwise I will not accept. Okay, I hope that is clear. Then don't message in WhatsApp saying this is my roll number, I do not have network or anything. Okay, when I tell you type your roll number in YouTube, you should type during that time, otherwise I will not accept. Okay, so that is also not that is all. Wait, we have to do some more questions, so I wanted to say that. Okay, don't type your roll number now, I'll tell you. I hope this is clear. Conversion of units is clear. Can you do now any type of problem based on this conversion from one system of units to another? Can you do? Yes or no? Yes, can you do conversion from one system of units to another? Okay. So let us go to the next type of problem based on this. So to check the correctness of a given formula, right? So this two questions are given to us. We have to check whether this formula that is given, right? So this is the formula given to us in this case, right? So we have to check whether this is correct or not. And also this one, right? So these are two questions, we have to check whether they are correct or not. Understand? So we can do that again using dimensional analysis. Okay, so first of all, this is what f is equal to mv square by r. Again, this is not, yeah, this is this form. Okay, okay, we have to check this. Okay, mv square by r square, we have to check whether this formula is correct or not. Understand? So how will we check? See, first of all, we have to know what are the things that are mentioned here. So it's written that f is force, right? M is mass, v is velocity, and r is the radius, right? So we have to find the dimensions. So let us find the dimension of f. What is the dimension of f? Dimension of force. Dimension of force. I have explained in the last class how to find this, right? I'll still do it once again. Let us say, so we have to know the formula. Okay, so force from Newton's law, you must have studied in class 9, is mass into acceleration. Mass into acceleration is force. So now mass, what is the dimension of mass? M. acceleration, we don't know the dimension of acceleration. So we have to know the formula for acceleration. Formula for acceleration is velocity divided by time, right? Velocity divided by time. So now m velocity, we know the dimension of velocity, and speed is same. You should know it's L t minus 1. This is the dimension of velocity, and time is t, right? So combining all of them, I will get m L, and if this t comes up, there is a power of 1 here. If it comes up, it will become minus 1. So t minus 1, one more t minus 1 will give us t to the power minus 2. So this is the dimension of force. Is this clear or not? If it's not clear, tell me. Is it clear or not? Yes, is it clear or not? Okay. So dimension of force, right? How to find out a dimension of force? So you should know a formula for that. Okay, the formula that I think you all know is mass into acceleration. Force is equal to mass into acceleration. So we can use this to find the dimension. How? So we can put the dimension of mass, because it's very simple, it's a fundamental unit, so we already know it's m, right? And we should also know the dimension of acceleration. But suppose you don't know, then again you need to put a formula for acceleration. Formula for acceleration is velocity by time, right? We will be doing this in the next chapter. So if you don't know the formula for acceleration and all, don't worry, just take it from me that it is velocity by time, right? So next, mass is the same thing. Velocity, the dimension you should know, because it's the same as that of speed. I have shown above, dimension of speed is Lt minus 1, right? And time is t, again it's a fundamental unit, so we already know that. Okay, so now combining all of them, so m is m, this L will come here, t, there is minus 1 here, and there is one more t, so I will do this separately here, divide by t. So if I take this t up, I will get what? T to the power minus 1, and there is a multiply sign between them. So again same base, add the power, so plus minus 1, so this will give me t minus 1 minus 1, which is t to the power minus 2, right? So that's how I got minus 2 here. Understand or not? Now is it clear? Who asked the question? Yes, Alinsha. Alinsha, is it clear now? Okay, so now next, so we know the dimension of force. Now we have to check whether this, so this is the left hand side force, right? We have to check whether the right hand side also has the same unit or not. Only then it will be correct. If the dimension on the right, this one, if the dimension of this term here is not the same as this, then the formula is wrong. It has to be same, okay, by the principle of homogeneity, which also I have explained in the last class. Okay, so let us find out. So what is the term on the right? Term on the right is mv square by r square. Now it's already given, m is mass, so what is the unit of mass? Capital M. V is velocity. Velocity units I have already given is Lt minus 1, but there is a square, so 2 times, right? So like that. R is a radius. Radius is a kind of a length, right? Radius is a length, so it will be L, and there is a square, so square. Okay, so now combining all of them, so I'll get m, there is a L on top, and let me bring this L also on top, so I'll get L minus 2, right? And okay, one more thing, so there is a square, right? So this will be L square. Okay, m L square, from this one L square, so that is the L square I have written here. This L minus 2 is the one that is coming from the denominator, I am taking it up, so that's why it becomes minus 2. T minus 1, but there is a power to the power 2, so it will become minus 2. Is it clear this part? Yes or no? Is it clear or no? If not, then tell me. clear, right? Okay. So now what will happen here? So this is m, same base, L and L, same base. So we add the powers, 2 minus 2, 2 plus minus 2, what will be 0, right? So L to the power 0 and T to the power minus 2. So this is the dimension that we got. For the right hand side, this is the dimension that we got. Is it the same? Are they same? Are they same? So if you look, m is okay, that is correct. L here it's 1, right? If I don't write anything, that means it is 1, but here it's 0. Again, T is fine, but L is not fine, right? It's 1 on the left side and 0 on the right side. That means they are not equal. Dimension of left hand side is not equal to dimension of right hand side. So therefore the formula is the given physical relation is incorrect. Okay, understand? This is incorrect. Okay, the formula that is given to us, F is equal to mv square by r square, is not correct. Is it clear? Okay. So that is incorrect, right? Let us do the number 2. This is number 2, right? This is number 2. Half mv square is equal to mgh. Half mv square is equal to mgh. We have to verify whether this is correct or not. Let us see what is the meaning of each term. So m is mass, v is velocity, g is the acceleration due to gravity, and h is the height, right? So g is your acceleration, h is a height, and v is velocity, m is mass. Okay, so let us see whether this, so again we'll do for right hand side first, or sorry, left hand side. Left hand side, term on the left hand side is half mv square. Dimension, so what will be the dimension? Half, it's just a number without dimension, so no dimension for that. Okay, so dimension of the left side, so this is a number, it does not have any dimension, it is a non-dimensional constant, so no dimension for half. M, dimension of m, which is mass, is capital M. Velocity, dimension of velocity is L t minus 1, but there is a square, so it will become this. Now if I combine all these, I'll get m, this will become L square, and this will become t to the power minus 2. So this is the dimension of the term on the left side. Let us find the dimension of the right side. So right hand side is mgh. So again dimension, so dimension is m for mass. Dimension of acceleration we have found on top, so it is L t to the power minus 2, and h is a height, it's a distance, it's a length, so it will be L, right? So combining, I'll get m Now there is one L here, one L here, so this makes it L square, and there is t to the power minus 2. Now look at them, they are equal, right? They are equal. So dimension of LHS, left hand side, is equal to dimension of RHS, right? So therefore given physical relation is correct. Understand, yes or no? Is this clear? Okay. Okay, so that is the second type of application that we have for dimensional analysis. Now the third one is to derive a formula from known quantities. So look at this question. The force F acting on a body moving in a circular path depends on the mass of the body, velocity and radius of a circular path. So suppose we have a circular path, suppose we have a circular path, okay. We have a circular path and its center is somewhere here, okay. This is the center, understand, and let us say there is a car moving on this road. There is a car moving on this road in this direction, okay. This is the direction in which the car is moving. So in order that the car remains in this path, right, if the car wants to remain in this path, there is a force that is acting on this, okay, that is pulling this car into the center, and if that force was not there, then the car would skid off, right, it will go off the road, understand. For the car to remain in the circular path, there is some kind of a force that is pulling the car towards the center, right, and that force is called your centripetal force, okay. We will learn about this in your in one of the chapters, right. So centripetal force, this force is the force that is pulling the car towards the center, and if this force was absent, then the car would skid off, it would not go on the circular path, okay. That's what I'm saying. Is it clear? What force I'm talking about, is that clear? Is the force clear? The force is clear or not? Okay, so that is the force that they are talking about in the question. Okay, in the question, if you see, the force F acting on a body moving in a circular path depends on the mass of the body, velocity v, and the radius of the circular path. Obtain a formula for the force, right? So they are saying that this force that is acting on the body, let us call it F, depends on three things. One is the mass of this body that is moving, it can be a car or anything, and next is the velocity v, and third one is the radius. These are the three things on which the force, this force F depends. Okay, so we will have to find a formula for this. Okay, so according to the question, the force F, first of all, it depends on what? Mass of the body. So we can write it's directly proportional to mass to the power something, right? Let us say that is A. So this A can be anything, it can be 1, -1, 2, -2, half, whatever. Okay, we have to find the value, we will do that. Okay, so first of all, it depends on this is number 1. Number 2, it depends on velocity. Again, velocity, we don't know what type of relation is there, so we will say v to the power b. And number 3, F depends on radius. Again, we don't know the relationship, so r to the power c. Okay, so these are the three things on which it depends. So let us combine all of them. Combining we get, so we can write F is directly proportional to m to the power a multiplied with v to the power b r to the power c. Okay, I hope that is clear to you. Now, so we need to find the value of a, b and c. That's very simple. We have to find the value of a, b and c. Once we get that value, it's done, right? So how to do that? So we have to compare the dimensions again. Understand? So what is the term on the left? It's force, right? Dimension dimension of force. I'll not derive it. It's, we have done this, so it's m l t minus 2, right? I am writing it directly. Now, so what about on the right side, right? So okay, so in this formula I'll substitute the dimension. Okay, in this term I'll substitute the dimension. Instead of writing force, I will write the dimension of force. It's m l t minus 2. There is a directly proportional sign here. Okay, I'll remove the sign for now. Let us call it equal to, right? And this will become, so m, what is m? M is mass, so dimension of mass is m. And what is the power? A. So to power a. V, what is v? Velocity. Dimension of velocity is l t minus 1, the power is b. And r is radius, it's kind of a length, so l to the power c. Okay, I hope it's clear so far. So m l t minus 2. Now here, combining all of them, what will I get? See, m to the power a, l, there are two l's in this term, so l to the power b into l to the power c. This will give me l b plus c, and similarly t to the power minus b. So far, is it clear or no? So far, is it clear or no? Is it clear so far? Is it clear so far? Okay. So now so look at these things now. Look, they are equal, right? Because it should be equal. So what is the power of m on the left? 1. What is the power of m on the right? A. So that means, so if we comparing LHS and RHS, we get, if we compare these two, A is equal to 1, right? Why? Because you see on the left, what is the power of m? 1. On the right, it is A, so they must be equal, right? So now, what is the power of L on the left? It's 1, right? If I don't write anything, that means it's 1. What is the power of L on the right? So it's B plus C, so that means B plus C must be equal to 1 again. And last one, what is the power on the left for T? It's minus 2. What is the power of T on the right? It's B, minus B, so B must be equal to 2. This part is clear or not? This part is important. If you don't understand this, tell me. This part is clear or not? Yes or no? Is it clear? Okay, look at this. Okay, they are equal, right? They must be equal if this formula is correct. If you want to find out the formula for this thing here, force is equal to something, then this must be true, right? According to principle of homogeneity. So you should write here according to principle of homogeneity, which I have explained in the last class, T, right? So this must be true. If we want to find a formula for this, then dimension on the left must be equal to dimension on the right, right? Only then the formula is correct, right? So look, dimension on the left is force, which you already know, it's ml t minus 2. I have written here, okay? But on the right we don't know, because we don't know the powers of, we don't know a, b and c, so we don't know what will be the dimension. So that's why I have just substituted the dimension of m, v and r, but exactly we don't know, right? But since they are equal, so whatever power is the power of m should be the same power here, right? Because you cannot carry the power from L and give it to m, right? You cannot do something like that. So they must have individual powers and they must be equal. That's why the power of m here must be equal to the power of m here. That's why the power of L here must be equal to the power of L here. Power of t here must be equal to the power of t here. Okay, that's what I'm saying. Understand? And that's why, what is the power here? 1. If I don't write anything, that means it's m to the power 1, right? So that's why a is 1. L power here is b plus c, and power here is 1. So they must be equal. B plus c must be 1. Here it's t minus b, here is t minus 2. So b must be 2, right? Only then it will be correct. A must be 1, b plus c must be 1, b must be 2. Only then they will be equal. Yes or no? Only then they will be equal. So that's what I'm saying, and that is what I have written here. Is it still unclear? Is it still unclear? Okay. Everyone, to everyone, is it clear to everyone? Okay, so that's what. Okay, so now a is 1, b is 2, but we don't know the value of c. So how will we find the value of c? We have to put this value of b here. We'll put the value of b in the second one. So b plus c is equal to 1, they are saying. So instead of b, if I put 2, so 2 plus c must be equal to 1. So c must be equal to 1 minus 2, which is minus 1. Okay, so a is 1, b is 2, c is minus 1. This is clear or not? This is clear or not? How I found the value of a, b and c, is it clear or not? Okay, now so I'll put the values now. A is 1, b is 2, c is minus 1. I'll put, let me call this equation 1. So putting the values of a, b and c in equation 1, putting values of a, b, c in equation 1, right? What will I get? F is directly proportional to m to the power a. So instead of a, I can write 1, v to the power b, b is 2, and r to the power c, c is minus 1. So proportional to m v square. What is to the power minus 1 means? 1 by r, so r. Okay, this proportional sign I can remove and put a equal sign, but if I put a equal sign, a constant comes out. Okay, so this constant is called the constant of proportionality. So this will be your formula for f. Okay, understand? But in the question, look at the question, they have told us take the value of k to be 1, take the value of k to be 1. So I'll remove k. So instead of k, I can put 1. So if I put 1, I will get mv square by r. So in fact, this is the exact formula. Okay, so the force that is acting on this car or the object that is moving in this path will be mv square divided by r. Okay, this is the force that is pulling the object towards the center, understand, and this is called your centripetal force. Now look at this formula. Just a while back we have done a question on this, right? Look here, this question, can you see this question here? F is equal to mv square by r square. So because they gave r square, that's why the formula was incorrect. If they had given us r, which is the exact formula, then it would have been correct. So you see why it's incorrect there? Is it clear why it's incorrect here? It's incorrect because there is a r square, whereas the actual formula is the actual formula that we have just found out is mv square by r. This is the formula that we just found, right? So if they had given this, then it would have turned out to be correct. Understand what I'm saying or no? Understand what I'm saying or no? Is it clear what I'm saying or no? Okay, so those are the three applications, understand? So first one, how to convert from one system of units to another. Second one is to convert from second one is to check your correctness of formula, and third one is to derive a formula. Okay, any doubts? Please type in the comment box if you have any doubts. Please type in the comment box if you have any doubts. Are you sure? Okay, you can type your roll numbers now. You have 1 minute. Okay, when I write stop, you should stop that time. Thirty seconds left. Okay, that's all. Right, so I hope it's clear the class today. The link will always be there. If there is something that you did not understand, please write there. I mean, please tell me. Okay, you can watch the video again and again, and if it's not clear, you can message me WhatsApp. Okay, understand? Any doubts today's class? In today's class, do you have any doubts in today's class? Any doubts in today's class? Okay, so I think now I have taught you everything in chapter 1 and 2. So do those problems in the end of the book, NCERT book. Okay, try those problems at the end of the NCERT book. Any questions that you cannot solve, give it to me. I will solve it in the next class. Okay, so see you in the next class. For now, that's all.